Hello all. So we are going to discuss about visible light communication. That is, whatever the lights we are using now in homes as well as in streets, that lights are going to be transmitted the data whichever we need. The data may be either text format or audio format, video format. Any type of data can be transmitted with the help of these lights. And only some modifications we need to do in the existing technology, that is Wi-Fi technology. And this is the content we are going to discuss about background working technology and where these visible light communication can be applicable, some comparisons about wireless technologies and how it is different from Wi-Fi, and applications, advantages, disadvantages, and some modulation techniques we will discuss about. So as we know, day by day how many mobile users are increasing, exponentially increasing the mobile users. Around 7.3 billion mobile users are connected to Wi-Fi, and around this number of bytes per month by 2018. As we know, these mobile devices are occupying most of the spectrum, radio spectrum, which we are using now. So by 2020, they are expecting 1000 wireless devices per a single person. That may be a laptop, mobile, or PDAs, or in smart home various devices will be connected. Likewise, 1000 wireless devices for a single person can be connected by 2020 to the Wi-Fi system. So if the number of wireless devices are increased exponentially like this, the energy consumption is also equal to the traffic of global air. So if we consider the analysis or the report given by YouTube, in 2011, 140 views per a single person on the earth. That is, if we consider all the population of the global, then this may be equivalent to 1 trillion views. And the networks which are created by United States of America in 60 years, that complete network is occupied by YouTube video within a single month. For every minute, 72 hours of video is uploaded, and every month 1.8 billion HD videos, 25% of global YouTube views coming from mobile devices. So everybody using smartphone, and always they are trying to connect with the existing Wi-Fi system. The average growth is reported as 48%. And if you consider the radio spectrum in 2011, only 0.6 exabytes per month can be used, where in the case of 2016 the usage is around 10.8 exabytes per month. So if increase like this, if you consider the last 3-4 years, the growth rate is very high. So if in future the growth rate may be increased more, and by 2020 there is no capacity of radio spectrum to cope with the existing demand. So in this radio spectrum shortage, already several countries are given warning to the population, people of their country, to the shortage of the radio spectrum. And how to fix this problem? So we have two possibilities: either identify new spectrum or enhance the spectrum reuse. That is, we need to divide the existing spectrum into more smaller cells. So it is not possible to divide more. Even if we divide more also, we cannot survive the Wi-Fi system more than 2 to 3 years. So that's why it is better to have a new spectrum. So this is the spectrum we are discussing now. So in this, the radio wave as well as microwave comes under 0 to 300 gigahertz, which can have high frequency, very high frequency, ultra high frequency, and super high frequency, extreme high frequency, terahertz, infrared, visible, ultraviolet, X-rays, and gamma rays. So the first part, the current radio spectrum is here. So this spectrum is going to be fully occupied with the various Wi-Fi devices. So that's why we have another option called visible light communication, which is widely available. Almost 10,000 more space is available than the radio as well as microwave space combinedly. So, and this spectrum is license free spectrum. There is no need to take any license, and whereas in this case this is a licensed spectrum. So we need to take license for the space we are going to use, but in this case this is different. That's why this space is more available, at the same time license free, and just now the research is going on this visible light spectrum. So the invention initiated by Alexander Graham Bell with the help of free space optic. This is the first implementation of photophone in the year 1880 with the help of free space optic. And let us discuss some background issues. Whatever the technology we are discussing now, that technology can be integrated easily with the Wi-Fi systems. Only the major issue is bandwidth. So to reduce the bandwidth problem, we have alternative called the visible light communication. For example, if we have a very crowded locations like coffee shops as well as airport terminals and some bus stops, so in these cases when more people are connected to Wi-Fi device, the bandwidth of Wi-Fi is shared among equally to all the devices. But in the case of Wi-Fi, whatever the bandwidth we have with the device, that bandwidth fully allocated all the devices which are connected to that system. So the first prototype was called as Wi-Fi, so which uses LEDs that are beyond the, not VLC, visible light communication, beyond the visible light communication, that is which is having infrared or microwave, which is not invisible for human eyes. So this system can potentially send data up to 100 megabytes per second. So even though some Wi-Fi systems are also having similar bandwidth, but as we said now, the bandwidth is divided among the people. For example, if some bandwidth is allocated for that particular device, so 5 devices are connected to that. Whatever the bandwidth we have, that is divided by 5, that amount of bandwidth allocated for each and every device. But in the case of this Wi-Fi, whatever the bandwidth we have, for example, that bandwidth will be allocated to all. For example, if the bandwidth is 100 megabytes, this 100 megabytes is allocated for all the people. There is no reduction or there is no bandwidth sharing. And this will be used in very useful in very crowded locations and high speed data transmission. Due to this, we can also stream the video without any interruptions. Another technology called Wi-Fi, which is Wi-Fi free space optic, that can increase the bandwidth of Wi-Fi systems by 10 times using optical transmission with the help of LED lights. And this is mainly designed for indoor applications. Why? Because in indoor we can omit the light that can be transmitted easily. If in the case of outdoor, there may be some interruptions with the help by sunlight or by some other external devices. That's why this is mainly used in indoor applications. We can call this as LED smart based lighting, so which can deliver enhanced electronic communication capabilities at reduced economic costs as well as environmental costs. There is no effect on the environment, at the same time there is no effect on the human beings. Another technology called smart light technology, in which what they did is they prepare a 3x6 box. In that 9 LED lights and 3 photodiodes they will place. These 9 LED lights will transmit the data, 3 photodiodes will receive the data, so that transmission and receiving can be done by the same devices. Some motivations are there. So in 2012, University of California enabled the wireless communications by embedding signals into light emitted by next generation LEDs. And this technology used for traffic control as well as advertisement and some other purposes. Same time, the LVX is another company, US based company, developing a system for internet communications firstly, but at the same time the same technology was implemented by the Japan, which is already used in that country. Infrared wireless LEDs, and which is same like infrared, that is invisible to eye and already widely used for high speed data transfer in the case of point to point communication where it is not possible to deploy fiber optics. Canadian technology is also there. Canadian they will working on free space optic, and which is using the line of sight communication, that is which is an alternative for microwave as well as radio frequency systems. In 2013, the Russian company Stinscoman announced the development of Li-Fi, and this network can be called as beamcaster. They are expected speed of 5 Gbps, but they achieve only 1.25 gigabytes per second. In 2014, and Csoft is another company from Mexico, and which is able to transfer the data up to 10 Gbps with the help of Li-Fi. So some discussion about introduction, which is a subset of optical wireless communication, and this on this technology the LEDs are used to transmit the data, and whatever the light bulbs we are using now, the same bulbs we can use. Instead of fluorescent lights, we can use LEDs to transmit the data, and to receive we are using photodetectors or photodiodes or image sensors, and which is like Wi-Fi, which is a Li-Fi is also bidirectional and with high speed fully networked wireless communication technology similar to Wi-Fi. So it is not a replacement for Wi-Fi, but both are required alternative technologies. So Li-Fi is a subset of optical wireless communication and can be complement to radio frequency, just like cellular network or Wi-Fi frequencies, or replacement in context of data broadcasting. So the Li-Fi can reach speeds up to 200 Gbps. The first prototype, a smartphone prototype, presented Consumer Electronics Show in Las Vegas from January 7th to 10th. What are the technology details? This LED as a medium to deliver networked as well as mobile high-speed communication in similar manner to Wi-Fi. So both Wi-Fi and Li-Fi transmit over electromagnetic spectrum, but Wi-Fi uses radio frequencies, Li-Fi uses visible light communication. So definitely the Li-Fi is expected to cheaper than the Wi-Fi devices, and we cannot expect long range with the help of Wi-Fi devices. Let us come to standards. Every technology has to be some standards. Likewise, Li-Fi is also having some standards from IEEE. In general, Li-Fi uses wireless protocols, that is 802.11 protocols, which is having much wider bandwidth. And in 2012, IEEE published a standard for visible light communication. And previously 802.15.7 is for metropolitan area network. But due to that out of date, the same 15.7 is used for short range wireless optical communication with the help of visible light communication. So what is the working technology? That is how it works. So as we know, depending on the intensity of LED, the data may be transmitted that much fast. That means if you want to do faster transmission, we need to have faster modulation. The modulation has to be done very fastly. So that's why almost whatever the intensity of LED, that intensity is modulated 10 million times per second. For a single second, it will the light was modulated for 10 million times. The intensity was modulated. And A single LED bulb can be used to transmit thousands of parallel data streams at high speed, integrating with modular chip. So what a single beam can be transmit with parallel data streams, we can call that as. So the transmitted data in the form of light rays is detected by the receiver called photodiode, which is integrated with a signal processor connected to our electronic devices. This technology allows both uplink as well as downlink communication. So as we'll see, we have a digital signal processing board and power amplifier, LED, and some internal connections are required to transmit the data. What elements we are using to transmit the data? The LEDs are transmitting the data. Instead of fluorescent lamps, we need to replace all fluorescent lamps with LED lights. And the receiving elements are either image sensor or photodiode we can use to receive the data which is transmitted by the sender. So some comparisons about Wi-Fi and Li-Fi. As we discussed now, the Li-Fi is using the visible light communication. So that's why we can simply call this as light-based Wi-Fi. So it uses light instead of radio waves to transmit the information. So Wi-Fi modems, instead of using Wi-Fi modems, Li-Fi would transfer transceiver fitted LED lamps that can light a room as well as transmit and receive information. So as we said, the two technologies are complemented with each other. So let us discuss some comparisons about the various technologies. We will divide the technologies into wired technology as well as wireless current technologies and future wireless technologies. In wired technology, the firewire technology we have, which can transmit up to 800 Mbps, and another technology called USB technology, and USB is the product of IBM, and we have several versions in USB: USB 1, USB 2.0, USB 3.0, USB 3.1, Type C, USB 3.1 second generation. So USB 1 is initiated in December 2000. Initially the capacity was 8 MB, and after USB 2.0, which was invented in 2003, and the capacity is 12 Mbps. USB 3.0, which was released in 2008, the maximum capacity is 5 Gbps. And later on, another technology called USB 3.1 second generation, which can transmit the data up to 10 Gbps. And the third technology in wired communication is Thunderbolt technology, which is the product of Intel company, and this also we have several versions like version 1 and version 2, but version 1 and version 2 are having the same connector. Version 3 is having USB 3.1 Type C connector. So in version 1 it can capable of transmitting 10 Gbps. In version 2 20 Gbps capacity, but that connector is having 20 individual channels, each is having 1 Gbps. And version 3 40 Gbps capacity and 2 channels, each 20 like that. And if we consider the current wireless technologies, we are using Wi-Fi, and this Wi-Fi can transmit the maximum speed of 150 Mbps. And another technology called Bluetooth, and in general this is a short range wireless communication device which can transmit within the range of 10 meters. And in this also we have several versions called version 1, version 2 and version 3. In version 1, which was released in 2002, version 2 which is released in 2004, having the capacity 721 kbps. Version 3 in 2009 having the capacity of 24 Mbps. And another technology in current wireless communication is called IRDA, Infrared Data Association, which is having the capacity of 4 Gbps capacity, and it is also very short range, which can capable of transmitting within 1 meter square, which was initiated by in 1993, and the association called Gigabit IR Association. And if we consider the future wireless technologies, the Li-Fi, which can transmit up to 100 Gbps, now they are trying to increase the speed up to 200 Gbps by doing some modulations. And Gigabit IR technology, which can transmit up to 1 Gbps, which was released in the year 2012, and this is also very short range, which can transmit up to 30 meter. And this needs line of sight communication. With the help of line of sight communication, this Giga IR technology will be worked. Another technology called WiSig technology, that is Wi-Fi gigabit technology, which is having the capacity of 7 Gbps, and this is also short range communication, and within 10 meters we can use. So the first version of WiSig technology was initiated in 2010, and second version was released in 2013. So this is using the latest modulation techniques called BPSK and QPSK, QAM, 16 QAM, and this is also worked in 60 Hz unlicensed frequency. There is no need of any license to use this particular technology. How fast it is? Depending on the light, it will improve the capacity of the Li-Fi device. So it can transmit up to 100 Gbps, but the technology we are using in light. So the average speed of a Wi-Fi device is 10 Mbps, but Li-Fi as fast as 1 GB, that is average speed is 1 Gbps. So the Passpar coated white lights, LED lights, are used in all commercial lighting devices which can deliver up to 100 Mbps. RGB lights, it can deliver up to 5 Gbps, and laser lights, which can transmit up to 100 Gbps. Now the research is going on to improve the capacity to 200 and 400 Gbps per second. And where these Li-Fi applications can be used? Almost everywhere, in every sort of for every sort of communication, it is possible to use this Li-Fi device. The first application was dense environments, like if you have a long hotel corridor and 24 hours, day and night, the lights are glowing. So in this case, if you replace all the fluorescent lights with LED lights, small LED lights, which will give a small lightning at the same time, which can transmit high amount of data to one person to another person. Cellular communication. If we consider the street lights, so if we replace the fluorescent lights with LED lights, a complete street can deliver high amount of data to one place to another place. In the same way, in cellular communication also, previously the distance is more, but due to the usage ratio, the distance came down about 200 to 500 meters. So instead of deploying a new radio base station in any city, street lamps could provide that particular transmission. And this Wi-Fi is not available in aircraft cabins, and when that is taking off, they'll announce switch off our mobiles and all the devices. Well, because the device may omit the radio frequencies, which may cause the interruption with the aircraft base station. So the signals may be interrupted. That's why they'll announce us to switch off our mobile. But if we replace the LEDs, then there is no interruption, and every person can enjoy high-speed data in aircraft cabin. Another application called augmented reality. So For example, if you consider a museum, when we visit a museum, there are several artifacts which were displayed on various walls. So if you fix one single LED bulb at each and every exhibit, so when we move on to that particular exhibit, the light will give complete information about that particular exhibit. Likewise, so instead of putting a printed material, if we place the light device, then which will transmit the information about that particular object or that particular artifact. The same way in advertising also, when we go for a shop, there are very big size advertisements. So instead of giving that sort of advertisements, we'll place one LED light in front of that particular product. So when we move on to that, it will give a complete information about the product, how much discount is offering, and what are the features, what are the advantages, what are the disadvantages of that particular product, which can be transmitted by the LED lights. And in case of Wi-Fi device which cannot work on the underwater, but the Wi-Fi is capable of transmitting the data within the water also. So the Wi-Fi can also be used in underwater where the Wi-Fi devices will not work. An intelligent transport system, in this also it is possible to use the Wi-Fi devices. Why? Because when we consider the highways, more number of vehicles are moving, and if we replace the car headlights with LED lights, then there is some sort of communication between two cars which are running simultaneously, and there is a possibility to establish a communication between the two drivers with the help of car headlights. As usual, smart homes we can use, and in health, in general, in any hospital there is no Wi-Fi, because the Wi-Fi devices are producing the radio frequencies which are harmful for health. But in the case of Wi-Fi, it is using visible light spectrum, that's why there is no harm for the health. That's why it is possible to use. Indoor navigation we can use. Everywhere, wherever we want, we can use that particular LED. And what the slide, the person we are seeing in this slide is Professor Aral Haas, and he is the initiator of the Wi-Fi devices from UK. Let's come to security. The Wi-Fi will provide more security than the Wi-Fi as a Wi-Fi device. Why? Because these Wi-Fi rays are not penetrating the walls, which will not pass through the walls. That's why even any person outside the room, he cannot access any information with the help of light. So the hardware prototypes. In general, we have a transceiver as well as receiver, and if we integrate these two, a single device may be used as transceiver at the same time receiver. Both operations can be done with the help of one single DSP board. So like this, we'll connect the LEDs as well as photodiode and some other hardware components that will be fitted to LED. This is a hardware prototype, and it will include two parts: the transceiver. That is, when we design a digital signal processing board, that has to be modulated. The chip has to be modulated. We need to have the modulated chip to convert the signals into appropriate format. So in this case, the OFDM analog signals and interfaces with the transmitter computer, and the analog, which includes LED array and some driver components, and receiver includes analog port, that is a photodetector or image sensor, and DC blocking stage and preamplifier stage. The same way the second also will see. So how this will be accessed? In general, if we consider the Wi-Fi, when we open the Wi-Fi in our mobile, it will display how many Wi-Fi devices are there. So we need to select one device to which we are going to connect. But in the case of Wi-Fi, if there is no network, all are having the same IPs. So that's why once we connect it to that particular device, Wi-Fi device, no need to again reconnect for another device. So what the industry we have right now. So this is the region wise some analysis and growth rate. North America year wise 2014-15 up to 20, and what is the growth rate? 83.9, Europe 85.4, Asia 79.5, and others 73.5. Total growth rate is 82. What the advantages of Wi-Fi? So as we know, which uses visible light spectrum, which is having 1,000 times more capacity than the radio spectrum, and we can enabling Internet of Things. We can connect more number of devices than the existing technology, and we can have a secure wireless communication, and the infrastructures also providing additional layer of small cells, and there is no health concerns. And it can also solve problems related to insufficiency of radio frequency bandwidth, because this technology uses VLC and it has not been greatly utilized. So high transmission rates up to 100 Gbps, and single light cannot penetrate walls. It provides privacy and security that Wi-Fi cannot, and low implementation as well as maintenance costs. This technology also some disadvantages, which any hard objects are there, the light cannot pass through the hard objects. At the same time, major challenge is how the receiving device will transmit back to the another device. So some interferences with external lights like sun and high voltage lights, as well as opaque materials. So, and it does not work in dark, and the big drawback is we cannot move from one room to another room after installing this.